Alright, so today we're going to look at examples dealing with slope. So, given 2 points, and using that, we're able to plug this directly into an equation in order to find the slope. So, before I begin, I'll begin by writing down this equation. So, slope is often represented using m, and is equal to y2 minus y1 over x2 minus x1. Another way of looking at this is the change of y over the change of x. Now, these subscripts, the 2 and 1, correspond to the given points. Right? So, in an example, we're asked to find the slope for the points 6, 5 and negative 12, 5. Before I begin, we'll start by labeling our points. So we have x1, y1, and we have x2, y2. And now all we have to do is directly plug this into our equation to find the slope. So we have m is equal to y2, which is 5, minus our y1, which is 5, over our x2, which is negative 12, minus our x1, which is 6. Subtracting this further, we get 5 minus 5, which is 0. Negative 12 minus 6 gives us negative 18. So our slope is just 0. Alright, perfect. So now, moving right along to the next problem, now we're just given a different set of points. Alright, so in our next problem, we're given the points 3.1 and 2.6 and 1.6 and 2.1. So we label our x and our y1. So this is x1, this is y1, this is x2, and this is y2. Perfect. Now we're going to plug this directly in. So we have y2 minus y1. So this is 2.1 minus 2.6 over 1.6 minus 3.1. So 2.1 minus 2.6, that gives us negative 0.5 over 1.6 minus negative 3.1 gives us negative 1.5. Multiplying that by 10, we get 5 over 10, and if I were to multiply both sides by 10 over 10, just so I can get rid of the fractions, we get a negative 5 over negative 15. We see that the negatives cancel out, they turn into positives, so the negative times a negative or a negative divided by a negative always yields a positive result. 5 and 15 can be reduced to 1/3. And then this is our slope. Perfect, perfect, perfect. Now, moving right along to our last exercise, we'll see if we'll look at what we get for our slope in that problem. Now, some things to keep in mind is that either we can have a positive slope, a negative slope, a slope that is 0, and a slope that is undefined. And each one of these slopes kind of tells us what kind of line we're dealing with. So it's really important to understand this concept of slope. Alright, moving along with our last example, we have negative 7 over 5, 3 over 10, and 1/5, negative 1/2. Alright, so just repeat that. Our x1 is negative 7 over 5, our y1 is 3 over 10, our x2 is 1/5, and our y2 is negative 1/2. Plugging this directly into our equation for slope, which we have over here to our right, we plug in our y2, which is negative 1/2, minus our y1, which is minus 3/10, over our x2, which is 1/5, minus a negative 7/5, which is our x1. So we'll begin with the top. We must establish a common denominator. So our common denominator between 2 and 10 is going to be 10. We're going to multiply negative 1/2 by 5 over 5. minus 310. Alright, and then this one can just work straight through. So we're just gonna leave this till the end so that we're just directly gonna work at the top. Multiplying negative 1/2 by 5/5 gives us the following value. Negative 5/10 minus 3/10. Now we have a minus sign followed by a negative sign followed by a subtraction sign. So that becomes a positive. So on the bottom we're going to have 1/5 plus 7/5. Adding this across, we get negative 8/10, and on the bottom we get over 8/5. Now we have a fraction divided by a fraction, and this is the same as doing fraction multiplied by the inverse of the denominator. So, well, sorry, not the inverse, but the reciprocal. The reciprocal of the denominator. So we reciprocate 8/5 to 5/8. Now we just cross multiply. We see that the 8's can cross cancel. We know that 8 goes into both of these numbers, whereas 5 goes into both of these numbers. So multiplying across, we have negative 1 times 1 gives us negative 1 over 2 times 1, which gives us 2. And our slope for this last problem is negative 1/2. And that is all.